Welcome everyone. This is our second lecture at Poznań University of Technology. Not sure if you had a chance to participate in the first lecture that took place the week before, where we were talking about in general about the BIM content, what the BIM content is, what are the origins, what it is for, how manufacturer utilize it. On today's lessons, on today's lecture, we will actually cover slightly different topic when it comes to the BIM content. For those of you which are pretty much interested in the content, I definitely recommend you to navigate to our site, bimstreamer.com, navigate to the knowledge, and under the knowledge you can also find the recordings from some of the webinars that we did in the past, which in general covers different aspects of BIM and BIM content in particular. And on today's lecture, I invited two of my colleagues, which will help us to slightly explain, to put a bit more light on the topic related with the preparation of the BIM content. We will actually cover on today's lecture two main platforms when it comes to BIM content, which is Revit and Archicad. And I would like to introduce our first guest, who was dealing with BIM content for Revit for past several years. In addition to that, he is also supporting us as within the BIM Streamer project to share with us his Revit knowledge. And in addition to that, he is one of the main content developer at BIM Drone. Ladies and gentlemen, I would like to welcome our first guest, Mr. Piotr Wolny. Hello, Piotr.
Hello there. Thank you for this invitation, and I think that things that I will introduce to you will be interesting.
I'm sure of that. And due to the fact that today, in addition to Revit, we also wanted to share with you some example with Archicad, I decided also to introduce our second guest, who is developing an Archicad content for many years. In addition to that, he's also supporting us within the BIM Streamer project as an Archicad expert. Ladies and gentlemen, Mr. Grzegorz Wilk. Hello, Grzegorz.
Hello, Marcin. Hello, all viewers. And yeah, thanks as well for invitation for this, I hope, interesting webinar today.
Yeah, I'm sure of that. So let's get back to our today's agenda. We will present you quite a lot of information today. That's why I also invited two of our guests to actually, so that you would also be able to ask them some questions later on, and also to share with you the knowledge that we're about to present you today. So what's on today's agenda? Well, first of all, we will do something like an introduction to the strategies that we're about to present to you on today's lectures. So we came up with several strategies. Some of them are available in several variants. And due to the fact that we would like to structuralize that at the very beginning of our session, we believe that this will help you later on to grasp all that information and being able to actually classify which, let's say, strategy is best fit for the content that you're about to create, maybe in the future, who knows. So each and every strategy will be divided in let's say, two main parts. In the first part, we will, or actually even within the three parts. So in the first part, we will explain you what the strategy is all about. Later on, we will run a short video demo just to give you, let's say, some tangible proof that the strategy actually works. And at the very end, our guests, our experts, so Grzegorz and Piotr, will share with you the findings. They share with you their, let's say, recommendation, which strategy is better or worse for any type, or for different kind of products, for different type of BIM content in general. And at the very end, we're also welcome if there are so many questions from the audience that we'll be more than happy to answer. So let's get back to our agenda. And due to the fact that that we're talking about the strategies, I think that the best way to start it is to quote one of, I think, the greatest strategies of 20th century. So Sir Winston Churchill said once, however beautiful the strategy, you should occasionally look at the result. So dear audience, today, the goal is to present you the results. So let's start with the classification I was telling you about. So we decided to split apart the strategy in two main subcategories, non-geometric one and geometric. For most of you, you're probably, for those that were on the previous webinar, probably this is not a surprise, but for most of you, it could be, because the BIM content, the BIM libraries might not have the geometry at all. So the products like paints, the product like insulation materials, or any kind of structural layer may not be shipped together with the geometry, but they do have the information. And of course, the geometry part, so the geometry category, is something which probably are most familiar with. And that's why, as you can imagine, we've managed to subdivide the latter subcategory further down. So we decided to divide it into another subcategories. The first one, we call it common, because this is the type of the strategies which doesn't require to create a separate BIM file for each and every BIM platform. So we would be able to use the same input for both Revit and Archicad. In some cases, we would be also able to use that for other platforms like Allplan or Vectorworks. And the other subcategory, called individual, assumes that we're creating an individual file for each and every BIM authoring tool. So this is not the end. We divide it further. When it comes to common, we differentiating two further subcategories. The reused one, which refers to the approach where we're actually reutilizing the existing BIM, actually not BIM, but rather CAD models, which most likely were used for the fabrication for the purpose of BIM. That's why we called it reused. Why the custom is when we're actually preparing the BIM content purposely, but due to the fact that we would like to have the single file that address several platforms, we're creating that within some specific way, which I'm about to present you in a sec. This is not the end. So the reused one are the one related with the step or 3D DWGs. Usually, when you would be a manufacturer, you most likely would create that kind of, it's called fabrication model, which later on are handed over to the production line in a tools like Creo, like SolidWorks, Solid Edge, Inventor. I will, let's say, I will use the Inventor as a separate example. I will tell you why later on, but we will consider Inventor as a separate, let's say, strategy or a variation of the strategy. And when it comes to the custom, within the custom, we decided to present you the Rhino platform as a platform where we can create the geometry, which later on can be converted into a format which can be accepted either by Revit or by Archicad. Both Step and Rhino is capable of actually transforming the geometry not only to Revit and Archicad, but on today's lecture, we're focusing on these two particular platforms. That's why we will skip the other ones. In addition to that, due to the fact that Archicad recently released a solution which is capable of importing the Revit file, we decided to also cover that as a strategy. So potentially we can use the Revit as an input for both Revit and Archicad, and this is going to be presented during today's lectures as well. Okay, so that's how we divided the categories related with the common group. So the common, which means that we're creating single file and we're reusing it for different BIM platforms. What about the individual one? We also had the possibility to subdivide that into further groups. So group number 1, maybe you are not pretty much familiar with that, but within this group, we've managed to prepare some sort of a generic content. I will tell about that when we will be presenting this strategy later on. But with the generic content, we're able to, let's say, reutilize the existing content across several different manufacturers with the standardizations like ETIM and ETIM-MC in particular, and this will be covered on this individual generic strategy. And the custom one, I think this is the most obvious for most of you. So the custom is when the manufacturer actually creates some bespoke solution, some bespoke content for each and every BIM platform from scratch. So this is the most typical approach. Probably most of the manufacturer follows this strategy, but during today's lecture, we will present them all. So we differentiated in general 5 strategies, which we number from 1 to 5. But if you look closer, you will see that 2 of them were subdivided in, let's say, 2 variants. So we had something like an issue in naming the actual naming the topic of today's lecture, whether we should call it 5 strategies or maybe we should call it 7 strategies or scenarios. So let's say we decided to meet in a halfway, and we call it 6 strategies, where 2 of them are, let's say, considered as 1.5. So I think that this was more like an intro when it comes to the strategy classification. Please, maybe if you have some opportunity, take a screenshot of this slide, because later on we will be somehow referring to this particular slide when we will be discussing each and every strategy. So as you see the numbers right here from S1 to S5, we will walk through each and every strategy one by one, explaining what the strategy is all about, what is the input, what is the output, what are the pros, what are the cons, and so on. But we won't refer to the classification anymore, so this is the last chance where you could do the slide. Okay, so let's start with the non-geometric one, so the one which is specific for the materials. When it comes to the materials, we don't need any geometry. So as an input, we just need the data. If you were on our previous lectures, BIM content introduction, probably you know that when it comes to the BIM objects, only the data are mandatory and geometry is optional. And this is the best example that confirms this thesis. So in this case, the only thing that we actually need is the data. As usually, we will use the BIM Streamer platform that most likely you will also use in the next semester to generate the content. So we will use the input data, put them inside the BIM Streamer, and as a result, BIM Streamer will generate accordingly Revit and Archicad file, which contains this set of information, which contains this set of content. All right, so in general, I will right now share my screen and show you some video. Give me a sec. So let's start it. I'm playing the video right now. Right now, we're within the BIM Streamer platform within the back office. As you can see right now, we are selecting, right now we've selected several different families that we are about to synchronize. Synchronize means generating BIM files based on the data and based on the geometry if there is one. So as you can see right now, we've selected 1, 2, 3, 4, 5, 6, 7, 8. 8 different families, and these are the examples that we're about to use during our today's session. So we decided not to, we decided not to synchronize, not to create the BIM content for each and every strategy. We decided to create it at once, and later on in the following strategies we will just present you the results. So right now we're starting this process of generating the content. Yeah, so the content was already generated. We will right now approve the content, because after the generation the content can be either approved or rejected. It's something like a quality check for the content. And now we're about to publish the content into online library that you see right now. So we've just created 8 different products which we are adding to the basket, and we will download for this product 2 types of files. Maybe I will reverse it a bit. So right now for these products we're downloading the Revit file and the Archicad file. These files were generated through BIM streamer platforms based on the Excel sheet which was imported into the BIM streamer admin panel called back office. Okay, so let's navigate right now to Archicad, and within the Archicad we can see that we're drawing the wall, and within the wall let's navigate to properties. I will forward it a bit just to focus on the most important part. So right now on the left hand side you see the Excel sheet that was used as an input file for the BIM streamer back office. On the right hand side you see the properties of the object within the Archicad. As you can see, the data which are on the left hand side, maybe it's not that clear because the orientation of the data are slightly different, but in general, believe it or not, the data on the left hand side are pretty much the same as the data on the right hand side. Okay, so this was more like an example of the presentation of the object within Archicad. Let's just check if the same thing is possible to be achieved in Revit. So right now I have a Revit on the right hand side, I have the very same Excel on the left hand side, and I will try to navigate to material settings within Revit to compare the data. As you can see, on both sides the data are identical, and they were injected within the synchronization process automatically based on the Excel sheet, and later on published and downloaded into Revit. So I think this was more like the presentation of the first strategy, and I would like to hand over the stage this time to Piotr. Piotr, if you could put more light on different pros, cons of this strategy, what is this better for, which kind of products are not suitable. Please go ahead.
Okay, thank you for giving me a voice. What can we say about this strategy? It's most suitable, as was said, for non-geometric content, which means mostly materials and other parameters which we can inject into content. And because it's not geometric, the geometry input is not required. Only information is useful for this kind of stuff. Sometimes even a data sheet and simple texture is enough to create that kind of content. It's a very quick solution. We're just inputting the parameters, the specific informations about this content, and actually that's all, I think.
So are there any obstacles? Are there any, let's say, disadvantages of using this platform? Because if it's quick and simple, why shouldn't we use it for all kind of products?
This strategy is only limited for non-geometric type of products. We cannot use it for something which has got a geometry. which often has. It's only limited for materials.
Okay. So in general, you said that it's good for materials. Like I think that you describe it very well. You use the word stuff. Someone told me once that everything which can be, let's say, provided in some sort of a boxes or bags is considered to be stuff, and the other things are things. So I think that it's, as you mentioned, it's more for stuff rather than for things like paint or insulation or different layers. So
yeah.
What it is not good for?
What is it not good for? It's not good for, I think, for projects as you said, like doors and any other things which has got geometry, because we cannot manage the geometry in that kind of strategy.
Okay, so thanks for the summary, Piotr. I think that right now we can switch to strategy number S2. If in the meantime you do have some questions, don't hesitate to write it down within the chat window, and in the course of this lecture we will try to answer them if we have some time. So go ahead with the questions if there are any. And let's go to strategy number 2. So the strategy number 2, as I mentioned before, is the strategy which somehow reutilize the existing data, 3D geometry data, which were initially created for different purposes. Most likely, they were created for fabrication. So as an input for this strategy, we use the step file. So if any one of you knows what the step file is, give me a sec. I will create a poll, and I'm pretty curious. What is your opinion? Do you know what the step is? Have you heard about the step before? Maybe in the meantime, Piotr, if you could explain what the step is.
Step is specific type of file which contains geometry. This geometry can be parametric, which is very useful for using in BIM content. We can steer it because it's calculated. We can say every time when we open this file.
So which platform actually natively, let's say, work with step? Is it some sort of a file which works with any specific platform, or it's rather something like an interchangeability format?
Mostly, I think it's interchangeable. I think it's interchangeable for many programs. Many programs can load the files with no problems.
So maybe now a question to you, Grzegorz. Why the step was actually invented? Why if different formats, if different programs has their own file format, why we should actually use step at all? Grzegorz, if you could put more light on that.
Well, the origin of a step file is exactly as Piotr said, for to have a chance to exchange models and information about models across different platforms, and hence that format it's very general. And the crucial thing with step file is that definition of geometry, it's based on surfaces and curves, not polygons. So it just handles the so-called NURBS models, like non-uniform rational Bezier splines. And and in addition to what Piotr said, of course, it is parametric, but in the way that since it has a capability of insert some inner parameters like metadata that you can create in authoring tool and pass it to another tool, but always the issue is what is the platform that you import this step file, because not every platform are capable of reading this metadata. And in addition, also, I would like to say that this step file, it's very similar because it's based on the entities, and it got the same origin or the same root as IFC file, and they are based on so-called express schema. It's like scheme of entities, like hierarchical set of entities that describe a type of elements. And when you open step file and IFC file in regular text edit software, you will see that this is just like text file when you can, it's readable, human readable file. And each definition, geometry definition, is just represented by so-called entities. And the most important advance of using the step files is this, that it can transform from one format to another with the least loss of quality of the model. And of course, some software that use that reads models as a polygon one, and they have to just transform it to polygonal models. And this is in the case of Archicad, for example.
Okay, thank you for the explanation. So I think that right now, if I would run the survey once again, the answer will be relatively different than the one that we got from you, because according to our poll, 65% of you have had no idea what the step was for. So as our expert mentioned, it was created mainly similar to IFC, mainly to exchange the data across different CAD platforms. So we use the step within the BIM, but in order to convert a CAD step into the BIM, we need slightly more effort. So what we did, within the Rhino tool, we converted the step file into the SAT and into the 3DM. So 3DM is the native Rhino file format, which is readable by Archicad. When it comes to SAT, SAT is a format which Rhino is capable of converting to, and later on we can open it within Revit. So we created the file formats which are readable by Archicad and Revit. These file formats were used within the BIM Streamer platform together with the data which were provided within the Excel sheet. And as a result, we've managed to generate two independent files, one for Revit, so Revit family, and the other for Archicad. So let me share my screen right now, and I will present you the how we did it. So I will wait until the screen is on. Okay, so right now, as I mentioned at the beginning, we're opening the Rhino, and within the Rhino we've uploaded some example wardrobe. Right now we converted it into 3DM and reduced the number of polygons and open it within the Archicad. All right, so I think I can even play it. As you can see, there are some attributes on the left-hand side within the Excel sheet. The Excel sheet was part of our input data, together, of course, with the step file. And in addition to that, on the right-hand side, we have the properties which are visible in Archicad. And right now, as you can compare on both sides, the data were injected into Archicad accordingly to the Excel sheet specified on the left-hand side. And actually, the same happened with Revit. Let me forward it a bit to focus on the most important part. So within the Revit, we did pretty much the same. So I think that was the example of the second strategy. I will right now navigate back to our presentation, and maybe I will this time ask Grzegorz if you could put more light on different pros and cons of the strategy which uses the fabrication content.
Okay. Okay, so, well, first thing I would like to say that these pros and cons, of course, they assume that we are in the position of a BIM content developer, and we speak with the manufacturer who's willing to create this BIM content, because mostly we will meet step files in a situation where manufacturer they have their native models, like fabrication models needed for production. And very often when we talk with the clients and ask if they have any models that we can create a BIM content out of it, they said, of course, we can provide step files, for example, as an exchange format. So this is advantage for manufacturer that they can use what they have at the beginning of the process. So there's no need to create models. So relatively, we can quickly create this BIM content, but the problem with this type of file is, first of all, we cannot create, well, BIM content, the main like specification of BIM content is that it's parameterized, but Piotr said that step file can be parameterized, but that means that we have this metadata, these descriptable parameters, but BIM content is parameterized in the way that we can change geometry in a specific way. That parameters can be changed with some constraints, and then they can control geometry and how the objects look and how they behave. And with the step file as a source, we cannot do it automatically. We are constrained only to very basic parameterization that we can do in the native Archicad or Revit environment. So, for example, we can simply create the possibility of changing materials or showing on and off, like turning on and off some components of those objects. But we cannot control geometry itself, like to stretch it in some smart way or adapt to specific conditions. And the second very important cons against this format is that since the origin of those models are in a fabrication, so they are very detailed. Since those level of detail is necessary for fabrication, like for CNC machines and so on, they have many elements that are not necessary for end user, like designer, like architect, that use it in BIM authoring tool. For example, like holes for bolts or some reinforcements in structure. This is something that completely is not necessary. Architects, when they use such objects, they need basic outlook of objects, and they are not interested, and there's no need to know what's inside. And very often when we import such step file through this middle software like Rhino, since step file cannot be imported directly to Archicad and to Revit, so that's why we have this Rhino as a middle software. And the possibilities of shrinking down the size of this object when it's converted to polygonal model, it's limited. So in some cases, it may appear that one object that we converted and put to the model has as many polygons as half of whole other elements in the project. So they can really slow down performance of the project. And so that must be kept in mind. And very often we use this step model only as a reference model, and we need to apply different strategies for creating BIM content. So what it is the best for, if we have it, it's for static objects. So mostly for furniture equipment, like interior stuff or interior things, sorry. So objects that are specific in the size, and only what we can change is materials, or we can turn it on and off some specific components of those objects, but without changing the sizes of geometry. So what it is not suitable for, mostly it's not suitable for map content, since map elements must be very lightweight, and they need only a basic geometry, just showing the sizes, the cubature, so they can be done in different way. And also for structural elements, like some joints and all those things that needs to be parametric, that needs to change sizes or positions and so on.
Okay, thank you, Grzegorz, for this explanation. Let's navigate to our next strategy. I mentioned that Inventor is one of the programs, one of the software that actually can be used for preparing the fabrication model. But due to the fact that both Inventor and Revit comes from Autodesk, we decided to cover the Inventor as a separate, I would say, sub-strategy, because actually Inventor gives us the possibility to convert, not through step, of course through step it would be also possible, but we can convert it through some intermediate file exchange format from Autodesk, which let's say from the data exchange perspective is more optimized for different Autodesk solutions. So what we did is that we start with the IAM, which is the Inventor file, usually as Grzegorz and Piotr mentioned before, used for fabrication. Then we convert it through the Autodesk Exchange format into the RFA, which later on was uploaded together with the data within the Excel sheet into the BIM streamer platform and generated the content containing the proper set of data. Right now I'm sharing again my screen so that I can show you how it actually looks like. Okay, so right now I'm within Inventor. I'm opening the Inventor file. This is actually a rack, and right now I will try to export this rack into this Autodesk Exchange format called ADSK. Here, as you can see, it's not that simple. It's quite sophisticated. I can select which data I would be interested in exporting. So I'm selecting materials, for instance. By default, it was unselected. And later on, I can see this information within the other Autodesk tool, within which I will open Autodesk Exchange file. And right now we're storing the Autodesk, storing the model, the inventor model. Here you see the confirmation that everything worked, and there was a question whether I would like to see the conversion report, so let's skip that part. We're opening the Revit, and as you can see within Revit, we've managed to open the ADSK file, and at the very end, we save that as a Revit family. I think the rest of the movie is the comparison of the attributes, so I think that we can skip that part because this is actually less relevant. I think that right now, due to the fact that the inventor is actually an Autodesk solution, why this strategy, how does this strategy differs from the step, and whether there are some specific pros and cons when it comes to this particular strategy. Piotr, go ahead.
About the inventor, when we are speaking with manufacturers, in many...
I think that the Piotr got disconnected, so maybe in that case let's continue further. So I will navigate to the pros and cons. I will try to explain you a bit, maybe not as good as Piotr could do that, but I will do my best. So first of all, when it comes to the inventor, it's pretty similar to the step file. So we don't need the geometry because we can reuse the existing geometry from the inventor file. Moreover, there is a very easy tool for preparing the content, since the geometry preparation is not required. The migration is slightly better because, remember, on the input we have the Autodesk file format, on the output we have the Autodesk file format. We don't need to go through generic step because we're still within the Autodesk, let's say, software family. As a result, it can be somehow optimized for the data exchange, and that's why Autodesk came up with Autodesk Exchange file format, which can be used across different Autodesk software. I think that it's pretty simple when it comes to inventor users. So if manufacturer has a team of modelers that were preparing the fabrication content for the production, it would be quite easy for them to convert it into other Autodesk file format. And I think this is something which I think standard step was missing, is the possibility to create a bounding box. I'm not sure whether you remember during our last lecture, we were talking about different LOD levels. So the bounding box is just, the box which somehow within which the final product could fit in. So I think that this is more like a simplification to the lowest possible LOD 100. So the inventor, definitely, if we're working with inventor, we don't want it to create a content from scratch, and our main goal is to work with Revit. Inventor could be an option. When it comes to the pros, the cons, well, the exchange is pretty much limited only to Autodesk file solutions. So if you would like to work with Archicad, this is not a strategy for you.
Yeah, anyway, you have to change to step file or
exactly,
and so just use Rhino as another middleware software.
Exactly. So we could somehow mix that. So if we work with Inventor, we could actually for Revit go through ADSK file format, so Autodesk Exchange file format for Revit, and go through step if we would like to go with other software. The good thing about the Inventor strategy is that we're able to address not only furnitures and interior equipment as with step, but when it comes to Revit, we're also able to keep the connection point and also work with detailed static objects which have some curves. So this would be more suitable for map terminals like stoves, like pumps, or sanitary equipment. However, if we need a quite sophisticated dynamic content which can be adapted, which is parametric, well, this is not the strategy for this kind of solution. So I think that this is more like a summary of strategy S2A, where we started with Inventor, ended up with Revit.
I would like to add something for this, because what I didn't mention with the previous strategies, we talk only about step files, and in the title of that strategies there was also a DWG format mentioned. And so with Archicad there is possibility to import a free DWG format to create the BIM content, to import geometry. So in this case, it would be possible to use Inventor to export the DWG file and then export it to Archicad. So that would just, there would be no need to use the Rhino as another middleware software. But of course, this is it's an individual thing for each object, and not sometimes it's importing in Archicad in a buggy way, so it's not very automatic solution.
Yeah, especially if we would like to work with a bunch of product portfolio, 100 or 1,000 of different product SKUs. So it could be a hassle, I would say. Okay, so let's navigate to the next strategy S3. Grzegorz already mentioned Rhino. So the Rhino is a modeling software which can be used for the fabrication, of course, not only the building equipment, but also the other equipment. Probably Grzegorz can put a bit more light on that in the pros and cons section. But let's focus on this Rhino strategy. So we're right now in the section where we will use the same input file for both platforms, but there is one slight difference. We're not reusing existing file which were used for different purposes for fabrication. We will create a brand new one. Thanks to creating the brand new one, we don't need to, let's say, rely on very high level of details of the fabrication model, but we can somehow optimize this content, especially for the BIM purposes. So I think that the strategy looks pretty similar to strategy S2. The difference is that we don't start with very detailed step, but we start with optimized Rhino 3DM file, which later on is converted to SAT. And when it comes to Archicad, it doesn't need to be converted at all. We can just use the 3DM as is. Then, of course, we need to remember about the data, because the BIM requires the product information. So we have them as usual within the Excel sheet. And as a result, we're able to generate a native files. So right now, I will present you the next scenario where we're actually using the Rhino as an input. So give me a sec. I will start sharing my screen. Right, so we are in. So right now, I'm playing the video, and as you can see, we're inside Rhino. So we prepared a chair in Rhino, and right now we will open this chair within Archicad, and we reduced the number of polygons in order to make it a bit smoother. And right now I can show you the comparison of the object properties after the generation of the file within BIM Streamer. So what we did, we had the Rhino file, we converted it to Archicad file, we synchronize it within the BIM Streamer, as you've seen at the very first movie that we presented, and right now we would be able to compare the data with the actual properties of Archicad object. As you can see on the right-hand side, the properties were. Give me a sec. I will maybe I will revert it a bit. Yeah, here. Yeah. So as you can see on the right-hand side, the properties within the Archicad is grayed out, marking them as disabled. Grzegorz, within the summary of this strategy, explain why these properties are grayed out by default, and I will just keep it. Let's say a secret right now. But we can also see that, for instance, for Revit, we did something pretty similar. So right now I speed up the movie a bit, and on the right-hand side you see the properties of not Archicad anymore, but the properties of the Revit file, and as you can see, they are pretty much the same as those data within the Excel sheet. So let's navigate back to our presentation, and I will right now hand over the voice to Grzegorz. Grzegorz, if you could put more light on the Rhino strategy.
Well, first of all, Rhino itself is a very powerful tool, and it's mainly used for product design. Its modeling engine works on surfaces and curves, so like NURBS surfaces, as I mentioned earlier. And also it's known, Rhino, for its big market of add-ons, and one of the most popular add-on is Grasshopper, that just provides visual programming into Rhino, since Rhino itself has a scripting platform, scripting module, where you can automate processes. And Grasshopper, I'm pretty sure most of you knows about, heard about Grasshopper. This is like off the topic, but this is the tool that also can be used in creating the BIM content. And now also Grasshopper has a connection both to Archicad and Revit, not only for creating BIM libraries, objects, but also other native elements like walls, slabs, and etc. You can create the whole BIM model through the process of visual programming. The case in this case, this solution is good because you can control quality and control the complexity of model from beginning. So very often, if we go back to the S2 scenario, even if we get this step file, and when we import it to Rhino, we can do both things. The fast solution, this S2 solution, just gives us the chance just to save it as 3DM or as a SAT file and export it to Archicad or Revit, so we can very quickly create that content. But of course, the chances of shrinking the geometry is very limited. So better solution, even in this step file, is just to model it from scratch in Rhino. We can control as I said, control the size of it and the complexity of the model. We can, for example, create several LODs of the same model and check how they are converted to BIM tools, Archicad and Revit. And the other thing is that Rhino itself, that they got, except of step, they got really like plenty possibilities of importing input formats as well as output formats. And we can also automate the process of creating this lower LOD thanks to this scripting functions. We can automatically create like these bounding boxes just to have this LOD 100, let's say, objects. So this is very powerful tool. And as I mentioned, we got the Grasshopper that just works with Archicad and Revit. So it's worth to pay attention on this software to get familiar with this. And in this case, as well as with the previous one, we don't have much possibilities to parameterizing the objects. Since we can only export elements, it's more than with the step anyway, but still it's just like we can define materials and say that this part of geometry, this component is has a certain material, as well as we can create this on and off options. So those cases are just similar. And very often it's used for creating this interior elements, interior equipment, and furniture, and stuff like that. And since it's based on this NURBS geometry creation, which provides us with the possibility of creating smooth surfaces, you know, like with fillets, with so it's good for sanitary elements like basins and baths and tubes and so on. But well, again, it's not very proper for creating anything that needs parameterization. So map components, well, this tool is it wouldn't be okay. I mean, we can use it, but then we will not have this automatic parameterization of map components. Those connectors will not be provided. We have to do it in native BIM authoring tools.
Okay, thank you, Grzegorz, for the explanation. We need to a bit catch up because we're in the mid-strategy and we have almost 2/3 of the time behind us. So let's get going. I would like to present you a slightly, let's say, maybe untypical strategy, which was, let's say, which is available not from so much time ago. And this strategy assumes that within the input, we have the Revit file. So you could consider that as an individual strategy because we're preparing the file in Revit, and we can use it, of course, for Revit. But in this particular case, we will try to also use that for Archicad, because Archicad recently equipped its add-on set within something which is called Rfa Rvt Geometry Exchange, which allows us to convert the Revit file like RVT and RFAs into corresponding Archicad files. Once we have them converted, we are able to synchronize the generated content together with the data within the Excel sheet and generate an Archicad file, in addition, of course, to the Revit file, which can be quite easy generated out of the Revit input data. So I will right now show you how the conversion to the Archicad file, to Archicad from Revit looks like. For that, I will again share the screen. Let's show how it works. So right now, I'm opening the Revit family within the Archicad, thanks to the Revit RVT RFA data exchange format. And right now, we're specifying the best match for a particular product that we're about to import. And we have actually imported a radiator. The very same radiator will be presented within the next strategy, but right now this radiator was actually created directly from Revit file. And don't forget, right now we're in Archicad. As you can see here, some of the properties are also grayed out. I think that Grzegorz forgot to mention that, but I think that he can actually put a bit more light why these strategies, why these parameters are actually grayed out. So Grzegorz, due to the fact that we're talking about Archicad, I think I will hand over the stage to you.
Yes, well, those parameters are grayed out by default. It's just a functionality of GSM objects in Archicad, and they are grayed out due to the fact that they are just descriptive parameters. They don't change geometry because they are not. This conversion just takes parameters from Rfa file and convert it to GSM, and those parameters, they don't change geometry, so they are locked, but we can easily unlock them. But since they are only descriptive, it's better to keep them locked because they got proper values right now. If we change them, those values will not resemble of what the object is.
Okay, so maybe I will also put a bit more light on that. So in general, as Grzegorz mentioned, when we're converting parametric object, which is available within the Revit file format, into Graphisoft, into Archicad file format, we're actually losing the possibility to make this content parametric. It's fixed, and if we would like to later on change some parametrics which normally in Revit would influence the geometry, it won't influence the geometry within the Archicad. The geometry will be fixed. And right now I'm presenting you the different, let's say, slightly different variant that would be more suitable for working with Archicad Rfa Rvt Geometry Exchange. However, right now it's still not possible. So as I mentioned before, we had the Revit file within the input, which later on we converted to GSM file. Then we imported both of these files, so Rfa and GSM, into the back office of BIM Streamer, which later on were populated with the data within the Excel sheet, and as a result, we generated two independent files, one for Revit, one for Archicad. But as Grzegorz mentioned, due to the fact that after the conversion, the Archicad file, let's say, it's a bit frozen, so we are not able to change the geometry. So even though we inject the data within the Archicad, which contains a different geometry, the geometry of the Archicad file won't change at all. The more desired solution would be to go slightly in a different way. So instead of converting the Rfa file to GSM at the very beginning, it would be more suitable to convert the Rfa file, which was generated based on the combination of input Rfa and the data within the Excel. So let's say that within the Excel, we had all the parametric values which are correct. Due to the fact that we have a native Revit file, we can combine these two and influence the geometry, and later on we would be able to convert it to Archicad. However, and that would be the most desirable way. However, well, this plugin does not support any API. API stands from Application Programming Interface, and in general, it is not possible to do that yet in an automated way. We're in a contact with Graphisoft and recommend them that it would be very nice if this API would be available. If that would be the case, then the S3A strategy would definitely be more powerful than it is currently. But I think that right now I can hand over the voice back to Grzegorz. Grzegorz, if you could put more light on pros and cons of this strategy in more details.
Mm-hmm. Well, the first and most important is this of this strategy is that we start from the point where we have Revit family ready, and that's the typical strategy, the typical starting point for a manufacturer. So they say, yes, we have a Revit content, but we decided to create Archicad content as well, and as quickly as possible. So that's the best solution for this. Only what we need is this information for synchronizing, but this is necessary for Revit format anyway. So when we got this family and those metadata, then we can create this static Archicad objects. But again, this is as previously mentioned, the similar situation. This is static geometry, and we cannot. Well, RFA objects, they can have inside the object. You can have many options, like many subtypes of geometry, and this add-on allows us only to save one state of this this geometry. So when we export to Archicad, we lose information about other types, other subtypes of this family. As you maybe noticed, this interface of this add-on is very simple. It allows us only to import as a 3 type of elements, like basic objects, windows, and doors. And there is no way to pass any other options that are in the Revit family. And as you mentioned, there's no API, so we cannot transform it in a more automated way. So it has to be done manually, in fact. And also in the case like this radiator, that was a map object that in Revit it has connectors that are active. When you exchange it, I mean, when you convert it to Archicad, this information about connectors are lost. Only the position of the connectors stays in the object, but they are not active, so they cannot be used in Archicad map modeler. So this is the disadvantage as well. So again, it's good for static elements when you want to quickly create some furniture, interior equipment, and so on. Or maybe if we got families with the simple elements of facading tools that we can then convert to panels in Archicad and use them as a components in curtain wall system. But as I mentioned, it has no parameterized. No parameterizing is passed to GSM objects through this conversion. So this is the disadvantage of this solution. So only metadata and static objects.
Okay, thank you, Grzegorz, for this explanation. So let's go ahead to next strategy. And right now, if you remember the hierarchy of the classification of the strategy that we presented at the beginning, we're shifting from the left side into the right side, where instead of using the common file for both platforms, we're actually creating an individual file for each and every platform. And as you remember, on the left-hand side of the right-hand side, we had the strategy which used the generic content. So before we actually going deeper into the strategy, I will ask you if you know what the E-team is. So have you heard about E-team before? Okay, so in the meantime, I see that we got some responses. Maybe I will start explaining what the E-team is, and please please add your responses on the way. So the eTeam is actually a classification standardization system that originally was invented in Netherlands, and it was actually mainly used by the wholesalers to simplify the work of exchanging a product information and as a result giving a quotation. So I will tell a bit more about eTeam and in general about different classification system on the next webinar, but long story short, eTeam was invented to actually specify codes for each types of products and codes for each types of attributes. I think I can right now close the survey. So as you can see, most of you had no idea what the eTeam is, but let's just consider eTeam as a standard naming convention for product types and for the attributes within the product types. So the eTeam actually came up with something which is called eTeam MC, and I will tell you why it is so important. So I will share the screen for a second. And as you can see here, here's the example of the eTeam MC. So MC states from modeling class. And the eTeam actually specify a standard of describing the geometry, in this case, for convector radiator. So as you can see, we have a different dimensions, DY36, BA, L6, L3, H3, and so on. So in general, if we would be able to create a generic content which is compliant with this drawing, the only thing that we actually need from the manufacturers is actually the actual values for these parameters. And as a result, we are able to reutilize the very same model, the very same BIM object for different manufacturers, because the only things that will differ is not, well, the general concept of the radiator. The geometry might vary, but only in terms of the values of these specific attributes. And that's how the generic content works. So it works similar to different templates. So I'm sure that you're familiar with different, for instance, website templates available online, where you can buy a template for, I don't know, $10 and then make your own site out of that. So the generic content, when it comes to BIM, works pretty much similar. So what we did for this strategy, we prepared two generic content which were compliant with eTeam MC, and in addition to that, we've also provided the data which were also compliant within eTeam and eTeam MC. As a result, we've managed to generate parametric RFA and GSM file with specific set of information specific for our particular case. We've managed to steer the geometry because we had the native files, but we didn't have to create content for each manufacturer independently. We could reuse the existing content that was created in some sort of a standard way. In this case, it was eTeam MC. Right now, I will show you how we did that. So start sharing my screen. So here you see the eTeam MC compliant objects for both Archicad and Revit. And right now, we will show you more or less how we've managed to synchronize this data in order to make them compliant with the input data within the Excel sheet. So as you can see, on the right-hand side, we have the data, the same one which were provided within the Excel sheet. As you can see, within the Archicad object properties, these data are being transferred over there, and not only transfer, these data also were managed to steer the actual geometry of the BIM file within the Archicad. And we did pretty much the same thing for Revit. So within Revit, I will focus on this Revit example in particular. We did the very same thing. We also steer the geometry of the Revit file thanks to the data which were available within the Excel sheet. And I think that this strategy is pretty unique when it comes to the previous one, because here we can actually steer the geometry, let's say, which is quite contrary to the examples that we had in the previous strategy. So right now I would like to hand over the voice to Piotr. Piotr, if you could in general put a bit more light on the topic of generic content. Maybe we don't need to focus on eTeamMC because the eTeamMC was used as an example, but if you could actually tell a bit more what are the advantages of the generic content and what are the cons of that.
Well, this is a solution finally that can that is parameterized, and this is the most important thing. And since it's made in separately in native software in Archicad and Revit, it can be optimized really to necessary level of geometry, level of detail, and also it's relatively fast to produce, especially that one type of element can be used for many manufacturers. It's just a matter of data sheet that we provide. And at eTeamMC is just one of the standards that we can use. That there can be just any other, even internal standards of manufacturer if he got just set of products. So in this case, we can use it very quickly. And the disadvantage, of course, it is that, as you could see, that those objects are on the low level, low LOD. So you cannot, so in an easy way and in automated way, create the fancy geometry that it's needed for design. Its simplicity, it's some kind of disadvantage in these cases. And the other disadvantage, let's say, but just creating the scheme of the list of parameters. It's something that if manufacturer doesn't have any, and if the object it's not in a standard, some general standard like at EMC, well, this standard has to be created with manufacturer or by himself or by the BIM content provider. So that takes a bit more time at the beginning to think about the concept of the object. And so it's good for highly standardized objects. It's perfect for MIP components, since they need lightweight geometry, as I mentioned before, and those geometry it's very specific and it's described by several parameters. So that's why it's good solution for this type of elements. And what is not suitable for anything that needs a high level of detail. So LOD more than 200 is, we can create some custom object that can read extra file with geometry, but this is more like the S5 scenario I will talk in a moment. Those two scenarios, they overlap a bit, but in this case, we can say that it's not suitable for extra detailed elements.
Okay, thank you, Grzegorz, very much for this summary. And in that case, let's move on to the strategy number 5 that Grzegorz has just mentioned. So the strategy number 5 is pretty much similar to S4. the main difference is that we are creating, let's say, a custom content. So we're creating a content from scratch in the form of a bespoke library. We don't reutilize the existing one, and this gives us the possibility to create, in general, whatever we like, whatever suits best for the manufacturer. I think that the best option is to compare this to, let's say, to buy either a suit at some shopping mall, which is the same for everyone that was about to buy it, and this would be the strategy number 4, while the strategy number 5 is the case where we're going to the tailor and they are actually creating us a perfect fit for us. Probably it will take us a bit more time, it might cost a bit more, but the adaptation to our needs will be definitely more accurate. And as a result, we're, of course, if we have two native files on the left, then we can also have two native files on the right. They are fully parametric because we can reutilize the native file format within the input, so we have a full variety of all the possible features which are offered by these two particular platforms. I think that within this case, it doesn't make sense to present you any specific video, because you can imagine that it could be any kind of BIM file. It can be even very specific one, which cannot be, let's say, cannot be somehow covered by some standard. Maybe it's very specific to particular manufacturers, and when they are creating that from scratch in a form of a bespoke content, then they are pretty much flexible in what they are about to do. So Grzegorz, if you could give us a bit more light on pros and cons of this strategy.
Well, as I mentioned before, this strategy is like extends the previous strategy. So when we take the example of this radiator, in this case, we could apply a higher level of detail by creating the mechanism of reading static geometry of this radiator, and to create the options of showing one or other type of geometry, but with the saving the possibility of applying in automatic way values for parameters. And this kind of objects, they are basically manufacturers who provides products that we could describe as a systems. So not a single product, but like a system. Like imagine a paneling system or baluster system, or a gutter or piping, anything, or anything that just consists of many components and that behaves in specific way. When manufacturer wants to be sure that the end user will configure it in the proper way, it can create such a library of these custom objects. And again, I have to apply it. And the cons of this solution, well, it's good for many things, but of course it takes more time to create, because since we are creating this from scratch, and we have to design the functionality, and that costs the time. It's time consuming, so it's naturally more expensive than other solutions. And with automation, there is a possibility to automate this process of creating this, but it's rather limited to only injection of data values for parameters. But thanks to this, we can create variations of that object. And of course, since we do it from scratch, and especially in Archicad, where we're scripting those objects, it might be buggy. I mean, that's the natural process of creating the software. that we have to debug such objects. And in Archicad, when we script in this, it's more obvious that we can create such commit mistakes. So this process may be longer, and it needs evaluation of the objects to see if it works correctly. So what it fits for? It fits for anything. Of course, for simple objects using this strategy, it's like maybe too complex. So you can do anything with this strategy, but of course, keeping in mind the price, the costs of creating this, it's better for a series of elements or systems. And well, there are no cons for that solution. If we have money and time, then we can do whatever we want. So
yeah, exactly, laying on the beach, as we can say. So Grzegorz, thank you very much for explanation and for this findings that we had from you. I think that right now is the right time to invite you for the next lecture, which will take place within a week from now. We'll actually cover the topic of the PIM, not BIM, actually BIM as well, but the PIM, which stands from Product Information Management, and we will talk a bit about the information within which is going to be shifted into the BIM content, how we should manage this information, how we could reutilize the mentioned today E-team when it comes to the product information, and of course we will explain all of this in the context of BIM and in the context of BIM content. So right now I think that we have something like 2 minutes, well actually 1 minute for a quick Q&A session. So if you have any questions, I think this is the best time to ask our expert or me. Are there any questions? Let's wait something like 10 seconds. If there aren't any, I think that we can pretty much. Okay, I see that someone is typing something.
Meanwhile, I would like to ask you, Marcin, if we can do a poll to our viewers, if they can say what experience they have with both platforms, just to see.
Yeah, sure. Give me a sec. So in the meantime, I'm running the survey. So guys, please go ahead. Type what are your experience. All right. So Archicad lost Grzegorz. I'm sorry in this case, but there are some people that are actually using Archicad, so it's not that bad. And let's get back to the question. Okay, so there was no further questions. I think that in that case we can close this session. We can close this lecture. I definitely invite you for the next lecture. I would also like to thank both Grzegorz and Piotr, who actually prepare all the BIM content that we presented during today's lectures, during the demo section. And I would like to also, in general, thanks our speakers and, of course, our audience. So thank you very much, and see you next week. Thank you.
Thank you. Bye.